So how do you divide by all the prime numbers that are smaller than our m? The easiest way, suppose you got number 27. And you want to divide, so let's say we are doing 5n plus 1 problem. So we need to divide by what kind of prime numbers? 2, anything that is under 5. So what is under 5? There are 2 and 3 are under 5 here. Then when you have number like 27 here, how would you know what kind of prime numbers would divide? Prime numbers less than 5 can divide this here. What you do is you do factor integer of 27. It tells you these here. Okay? What does it mean? It's 3 to the third power. So this is the number. So the first number. So I will make this case more complicated so that you can see here. Let's say I got 2 to the second and 3 to the second and 5 to the second and 7 to the second. So this is the number we are dealing with. And when you factor the integer here, of course, you will say 2 to the second, 2 to the 3 to the second, 5 here. Then suppose our n, we are doing 5n plus 1. Then anything less than 5 should be divisible. So how do we pick that? So I got to pick these, right? Anything is less than 5. So what we do is that when we get this result here, let's call it Q. Out of Q, you will select the first element that is less than the number we are dealing with. We'll call it M. So in our case, M is 5. So we'll that is the same M that we are using here. So if it's M, then we're gonna pick it. So that means that. So the number we picked here, this number we have here, let's call it mystery, equals this number. Copy, paste. So that's the number we have here. So I will call this mystery. So I have to divide this mystery. So new one will be mystery divide by 2 to the second and 3 to the halves. How can you construct it? Let's call it stuff. Suppose somebody gave me stuff. How do I make this into the number I want? So what you have to do is you got to do the map here. And then what you do is that it has to be first number to the second number, you see. So it has to be first number to the second number. That's what I'm going to do with stuff. Let's see. Then it worked. 2 to the second is 4. Then 3 to the second is 9. But I need to multiply these. So what do? You do apply times to the result you got. Then you get this here. So 36 is the number that you can divide. So what I do is I will just copy the whole thing and paste it here. Then it tells me is 1, 2 to 5. So what it guarantees is that this guy doesn't have any factors that are less than m. Want to see? I will do integer factor integer of the result I just got. See, it has no factor that is less than 5. So maybe we should include 5. I wonder. Maybe we shouldn't. So it is a matter of just having the equal sign or not. So you can explore that here. Okay. So how do we put this in here? So now we got all these building blocks done. So we are not going to check is even n and then divide by 2. Instead of dividing by 2, we will be dividing by this guy, right? And we don't have to check if it's even, because prime factorization not only tells it it's multiple of 2, it's also telling me that it's multiple of 3, 5, and 7. Tells me everything about it. Okay? So now, all you got to do is just do a prime factorization. So let's do here. So we don't have to do if at all. So let's see. I will call it Collatz02, and I will copy this guy. But here it's not going to be simple operations like this anymore. So I'm going to change it. I will say module. And I will have local variable space. And then here we go. So what I will do is I will do a factor integer of n, the number I want to deal with. So let's call them divisors. And let's make divisors to be the local variable here. So when I do divisors here, what I got is these things here, right? Of which we have to select one that is less than m. So I will copy this. So I got the divisors. So this is my divisors. So all those, the first number has to be less than m. I happen to use the right variable, so I will get it. So here, these are the, how do I call this? Numbers that you should divide by. Cut. So that's the local variable. So from this, well, the result you get, you saw it. It's going to be a list like this. So you got to turn this to a solid number. So this is what it is. So I will just copy it. And I have to give a name. I will call it div factor. Is apply. I will make it a local variable, div factor. And I am going to do, it's not stuff. This is cut. Other than that, everything is right. Okay. And then, what do? We got to divide it. So we'll take the original number, which is n that came in. So new equals n divided by div factor. So I got the new one here. But here, this is place that I need to have if. Because if it doesn't have any divisor, then I got to do this, right? Only when it is divisor, I'm dividing. So I'm doing this part here, but I got to do this part as well. So I have to check if there was any div factor here. So in fact, I had to see here. When I did select here, did anyone survive? So let me show you what I mean. Suppose the mystery number was this here. So let's call this mystery. Okay. Then I did this, and I select the number, a factor that is less than or equal to 5. And I got nothing here. So this is the equivalent of odd number in our original case here. So I have to actually do this here, and I got to see if I got something here. So if the cut was equal to empty, then what I have to do is this. So literally, I got to do this. Copy and paste. But what if it was not nothing, it had something in it? Then I will be doing this. So this is what I compute, and this is the number I get. So therefore, what I return is new and m. That's it. Let's make the new to be our local variable. Okay. So this should work, I think. Okay. I have error. I started the module and I didn't close it. Let's see. What is this then? Let's see, apply. Control Shift B tells me it ends there. So that's fine. Oh, I didn't close if. There we go. Tag function is protected. I set delayed write tag a function in function and nest while. Why is nest while showing up here? I'm still debugging this, but I realized I made a mistake here. See, this division by 2 should not be happening anymore because I'm not using even odd anymore. So I should just get rid of this. So instead of 3n plus 1, I could have been doing 5n plus 1 and 7n plus 1 and so on. Okay, but still don't get why this tag function in function and nest while is protected. Where do I have that? B. But why is this coming up here? I don't get it. Let me just run this. This one goes fine, but this one doesn't. Set delayed right. Tag function in function. Did I have a conflict of name? Let me see call3 and see if it works better. I used the same name twice somewhere before. So that's why it was happening. So here, I got this. So it's not a problem anymore. So I will call it call M, because I'm using M multiplied by M business here. So call M is this. Okay, so this function is finally made. Let's see if it works. Call M. If I say 27 and 3, it should work the same way. I got to pass it inside the curly bracket. Okay. Cannot tell. Did it multiply by 3? So let's make it 8 here. And it divide by all the factors of 8. So therefore, it see, if there was normal Collatz here, say COL of 8 and 3, you would have gone through 3 steps. Then you would put 4 there, and you get 2, and you would put 1 there, 2 there, and then it becomes 1 here. But this one knows that 3 is made of 2 to the 3rd, so therefore it just cuts all 8 in one shot. So this would be easy to see if it works here. So let's see. I will put 9 here. Then I will put, I put 11 here. Then let's see. I will say it's 2 to the 3rd times 3 to the 7th and 5 to the 3rd and 7 to the 3rd. So this is a huge number. But see, all of them have factors that are less than 11, so therefore it should divide and give me just 111 at the, not 1 and 11. Yeah, 111 at the end. Let's see. There we go. It worked here. But if I introduced a factor that is bigger, such as 13 to the 7th, it will give me 13 to the 7th as the answer. This is 13 to the 7th. Wanna see? Goes like that. So it is working as advertised. So we got mighty powerful function that could cut down Collatz with all the factors that are available in one shot.